Hello, you're listening to Streaming Audio, and I have a challenge for you. Scan the whole of the internet, save the interesting bits, as regularly as you possibly can. That's a lot of data, and this week we have a story that is genuinely web scale. We're talking to Jared Smith and Brandon Brown of SecurityScorecard. They do web security and security threat analysis. And scanning every IP address on the internet is just one of their data sources. So you can imagine the capacity they need to stream data in at scale and to process it efficiently. We end up talking about their journey from using RabbitMQ in the early days to the way they're using Apache Kafka today. We talk about the upsides of being able to ingest that much data and some of the problems it brings. And we also explore how they're helping the teams around them to both create and consume new feeds of data now that they have a platform that can actually cope with it. So Streaming Audio is brought to you by our education site, Confluent Developer. More about that at the end. But for now, I'm your host, Chris Jenkins. This is Streaming Audio. Let's get into it. I'm joined today by Jared Smith and Brandon Brown. Gentlemen, welcome to Streaming Audio.
Hi, good to be here.
Hey, thanks for having us.
Good to have you. So let's see, Jared, you are this almost sounds like an FBI title. You are the Senior Director of Threat Intelligence at SecurityScorecard.
Yes.
And Brandon, you're the Senior Staff Software Engineer, right?
Yep.
Okay. So Jared, I think we should start with you being a Senior Director. What's SecurityScorecard? What do you guys actually do?
That's a good question. It depends on who you ask, but just for the sake of how we usually describe ourselves, and for the people that aren't familiar with security ratings, you can think of it most similar to credit ratings, but for cybersecurity. And that's a horrible way to explain any company. Might start at being Uber for food delivery or whatever that may be. But that's a great way to think of us. So the world has lots of security problems. That has lots of things that we need to put into place to protect people from threats, protect people from getting phished, all of those sorts of things. And we're really good at identifying that risk and bubbling it to the surface for the people that need to know how to address it, where to address it, how to improve, how to protect their network.
So like detection and advice on how to solve it afterwards.
Absolutely. The remediation is a huge key as well. Yes.
Yeah, I can imagine. Give me one example. What's one kind of threat you deal with?
One simple example would just be simply people leaving ports exposed on their network. Imagine that you have a login for a cloud server, and that's on your network. And when you are testing it in development, you forget to bring it down, but it's still connected to a production database. That's a risk, because if somebody finds that, or there's a 0 day in that box, or it's a reused password, that can then lead to bad things inside your network.
Yeah, absolutely. Okay, in that case, I'm going to head over to the Senior Staff Software Engineer. Give me a spicier example, Brandon.
Spicier example. So one of the key things is that all of the kind of data aggregation we do is all from the outside in. So we don't actually go into your network and scan. All of our scanning and data collection is all from publicly available information. So that's a key differentiator as well. So for example, one of the products I work on, AVD, automatic vendor detection, we actually take the data that Jared's team produces and we automatically make connections saying, because for a simple example, you use Google, and we know that because you used a Google tracker on your webpage. It's a kind of super simple, easy to follow example.
Right. Yeah.
And so we pick these things up automatically. And so what's really exciting is larger companies that are trying things out expose themselves unintentionally. We actually had a customer who we said they were using HubSpot. And they said, we stopped using HubSpot years ago. And we look at the raw data, we go, well, on this date, we saw a link to HubSpot, and sure enough, an internal team was experimenting with HubSpot. A small group within that company was aware of it, but the larger company was not. And so this was a potential risk to them because they didn't know, and we were able to point it out for them automatically.
Because this is a thing that a lot of hackers do, right? They start by auditing what their target does and doesn't have.
Yep.
Yeah.
Right. So you've got to get the jump on it. Okay, I get the idea. Jared? What kind of scale are you doing this at?
What kind of scale?
Yeah, are you like dealing with dozens of customers, or what's
We're,
your?
we're thousands of customers, but even on my team, we don't even think about the number of customers we have. We think about the number of possible digital assets, digital indicators that we can track.
Right.
So that's where Confluent starts to come in. I mean, there's 4.1 billion IPv4 addresses. About 3.9 billion are actually routable. That's not even thinking about IPv6. And one of the most fundamental things we need to do is constantly be aware of what's on all 3.9 billion of those routable IP addresses in a week to week and a half basis, if not faster. And so
Right.
we need to talk to every single one of those, and we need to spend a few minutes assessing the security risk of each of those. And that's a large number, but we also deal with billions of accounts online that we found in data breaches, and we've got to process those. We're talking about hundreds of millions of hits a day in our honeypots that are in 63 countries that are just pulling in attacks that people are running out there that has to be streamed back to Brandon's teams to actually put into our platform. So the scale is essentially limitless. It starts to get pretty large pretty fast.
You're attempting to scan the whole internet plus other stuff.
Yes.
Okay, yeah. That will do it for scale. So maybe we should bounce back to Brandon. Can you give me an idea of the basic architecture of what you're doing and where Kafka comes into this?
Yeah, so in regards to the product that I work on, we actually take a feed from Jared's Kafka cluster, which is just raw JSON, and we only care about a few specific entities in that topic. So what we actually do is we fan it out into a different cluster, and we standardize all those messages as protobuf. And so what's great is we get very compact messages in our topic, and then we also get the speed and efficiency of we can just subscribe to whatever feed of entity that we care about. So when we actually went GA, we had a single entity we cared about. We very quickly were able to add on 2 additional entities just by saying, start consuming these topics. And just for kind of an example of scale, we had an issue where the message sizes increased. And so our fan out process was working fine, but our consumers actually were out of memorying. And so we ended up building up over the span of about 4 days, a 6 million message backlog. And we were able to, just by increasing memory, go ahead and process those 6 million messages in under 8 hours. And if we wanted to, we could have done it faster. We just would have had to do some more tuning and tweaking. But for our use case, 8 hours was perfectly acceptable. And so that was pretty exciting, actually, to see that happen, to see us be able to get caught up from that in less than a day. And it didn't even choke our system. And we've seen other batch-based approaches, when that scale of data comes in, they just fall over. They have to reconfigure a bunch of things just to get caught back up. So this was a really powerful use case for, one, using Kafka, but also using specific message types and kind of splitting out your data in ways that work.
Yeah, that's in those circumstances, a lot of companies wouldn't be able to catch up at all. They just throw away that missing data in the meantime and just have to pick themselves up from scratch. It was
actually a really funny thing that happened, because I saw the alerts happening and I was like, oh, it's just the infrastructure being weird. There's not a problem here. And then coming to work Monday, and I'm like, actually, something seems really off. And we were able to quickly triage the process, which basically consumes those messages, does some processing to make connections, and then saves to a Postgres database. And what was great about it is we got a delay in data, but we still were able to serve up data because we kind of segmented our services in such a way that delay in processing didn't affect the actual serving up of the data.
Okay. So you're essentially using an architecture where Jared's team is pumping into one cluster, just gathering raw data.
Yep.
And then handing over to you guys for analysis.
Yep. And what we do is we kind of do the standardization of that data. So making sure that the fields follow specific naming conventions, so that you can just read those messages and not have every consumer do the pricey thing of okay, well, how do I map this field into this entity? Oh no, the casing of it changed. Now I got to update all my code. We handle all of that standardization, so you can trust everything in our cluster is already standardized.
Okay. So, and you're doing that so that you can just slurp everything from the internet in as fast as possible and then worrying about tidying it up later.
Yep.
And then the downstream people don't worry about tidying it up at all.
Yeah, and what it lets you do is kind of create this approach of let's take in all of the things and then let's be really focused on what are the things we're sucking in that we actually care about, and let's give time and attention to making sure those are good. And so you can kind of work in this iterative approach where you continually add on things without having it all perfect up front.
Yeah. Because in a perfect world for a system like that, you'd say, okay, load the entire internet into memory
Yep.
and then start filtering it, right? So you're kind of doing something like that.
Yep.
Yeah, that makes sense. How long have you been working on this system? Or how long has the system been alive? Jared.
Oh yeah, so AVD in particular. I mean, we've been working on it since last fall, but it went GA in the spring of this year, the early winter.
Yeah, actually,
right?
it went GA early January
Early January,
was
yeah.
the first iteration, and then the spring we had a additional product data feed that we onboarded.
And then we've been using Confluent and just Kafka more broadly to do the internet scanning since January of 2021. So it was a whole story of moving off of RabbitMQ, which we had for years, to Kafka, which immediately scaled like almost seamlessly. I mean, basically seamlessly. The only non-seamless piece was just managing the on-prem infrastructure with Confluent. But I mean, that was still better than running our own cluster in something like MSK. And that really ties into our story, because as soon as we started sucking in data, we weren't going to limit the speed at which we would scan the internet or the number of ports we would scan, which we had to do with RabbitMQ because it wouldn't scale. But that was just fundamentally not going to be the thing that blocked us. So if Kafka wasn't able to handle that amount of data, then that wasn't going to be the right solution. But it works. I mean, that's what it's designed for. It's designed for a massive amount of data. It's designed to be able to track it, replay it, process it, all of that. And we've been able to just scale in terms of new data we collect for our customers just by adding new topics and new collectors. And so a lot of our collectors are Python, basically Python programs that we distribute around the world in different boxes, or we run crawlers. And they all just produce a Kafka on different topics. And that's the super simple way to scale up all the different types of data we bring in that we then surface to customers upstream.
Yeah, it makes sense that I can tell just from talking to the two of you, you've separated out reads and writes very nicely.
Yeah, and
Conway's law seems to be working for you.
And the beauty of it too is that because they are separated out, it's very easy to improve upon one of those systems without having this kind of monolithic, oh, well, this change is held up by this other team system. We can work in parallel independent streams. And the other thing, when I came on about a little over a year ago, was I did not want to manage on-prem Kafka at all. So we actually had MSK, and it was not meeting our needs. And so Jared got me connected with Confluent, and we started using cloud from the get-go. And as soon as we were able to do an annual commit, we were able to use Kafka Connect, and we were actually able to take in our service a lot of expensive REST API calls and eliminate them completely, because we could use just Kafka connectors to stream from upstream databases and save off the information we wanted so we could do lookups. So what's really cool about our AVD data set is now officially any piece of data that constructs it lives in a single database, in a single schema. You can query it and play with it and interact with it without having to go hunt down various sources of data. And so it's allowed us to actually fix bugs really fast as well because of that.
So you use a fair bit of Postgres as like the last loading layer before the presentation layer? Is that what you're saying?
Yep. We actually do some really cool, I like to call it using and abusing Postgres. We have a materialized view that we're using that because of indexes that we could put on it. But that basically gives you, for all of the things that we rate and score, all of those companies' third parties. And that materialized view is about 42 million rows. we can concurrently refresh the materialized view every hour, and it takes about 20 minutes to concurrently refresh. So every hour, we're updating the data. We are able to then use that to calculate your fourth parties as well, which then obviously that 41 billion rows expands out much higher. And we can serve up that data in a matter of seconds. So for example, a company like Google, we can get their third and fourth parties in about 2 seconds, which is
Because this
pretty
is an
awesome.
important part about security, right? You trust Google, so you include their tag, but who are they using and what security issues have they had? And nobody really tracks that firsthand, right?
Right, and that's actually, if you look at a lot of the big breaches that have happened in the last few years, they're not directly because of your third parties, they're because of your fourth parties, so your vendors' vendors. And something that just, large company acquires another company, and that other company previously acquired some company that doesn't have good security, and it opens this attack surface. And so that's part of the work that Jared's doing and that I'm doing, is helping surface those in a much more easy to digest and track manner.
Yeah. As they say, the friends of my friends are also my friends, but it doesn't mean that they're good at security.
Yep.
Yeah. I like that. I'm going to have to reuse that.
But I want to jump back a bit because I really want to dig into this. Jared, maybe you could take this part. So you started off with RabbitMQ. And I always like to know, at what point do people say this is painful, we need to move?
Yeah, no, absolutely. So the RabbitMQ was used for a while before I joined in 2020, almost 2 years ago in November. But the point that became painful was asking to add a single port to our scanning. So we were doing at that time something like, I think, 80 ports internally, and we had some other ports we brought in from external providers. Other scan providers, and I wanted to add ports. So like, can we scan this port, this port, this port? And there was no consensus on whether that would bring down the system or not. Like the actual streaming,
just through sheer capacity,
just through scanning, another 3.9 billion IPs, and if they have that port open. Like, yes, it all happens at the same time. All the ports get checked at the same time. But if that brought too much data back, no one was really sure whether it would knock the system over. And so that was the leading technical limitation. And at the same time as well, though, we were being asked to move all of our scanning in house. So moving off third party providers and bring it all in house. So there's a few companies out there there's one called Shodan, one called Census, that you can type in all webcams and you get back all webcam IPs. And so that was what we were tasked with essentially building in house, because we weren't going to rely on someone else. And at that point, it was immediately clear that if I needed to be able to scan more than 1,400 ports, which is what we do now, and is pretty standard, then we needed to be on something more scalable, because we just can't that scanning process in all the other collections. It is the root of our company's livelihood. If we don't have the data, if we don't have the insights, if we don't have the research, we have nothing. We can't visualize things to customers. We can't attribute it to their network. We can't alert them about breaches if we don't have the data. So we really we were in a scramble to be like, what is the right choice? And I remember back I spent 6 years in the U.S. government doing intelligence research with DOE, power grid security.
You were an FBI agent. I knew it.
I actually work with the FBI more here than I did there. I worked with the NSA a lot more there. It was the NSA, it was the CIA when I was in the U.S. DOE. But what I was getting to is we played around with Kafka back in 2017, 2018, before I joined here in 2020, and we loved it. It wasn't nascent then, but it wasn't it was something we were using the open source version of. So I had this bug in the back of my head back in jump forward to 2020 or 2021 when I was building this here. And I was like, maybe I should just try Confluent on-prem. In our platform. And the reason we did not platform is because at the time we were running scanners in really sketchy places, which we can talk about in a bit. And I didn't know about streaming data from mainland China back to Confluent Cloud's clusters, or from Russia or Iran. So talk about that later. But I downloaded it, and when I hit the license limit, I was like, man, I need to sort this out. So I asked my boss, Ryan, and then he was like, yeah, like, dude, whatever we need to do, we need to make this work. And it was just me and him at the time before he hired the whole team to really take over the system and bring it to where it is now. And so I reach out, I mean, I kid you not, like on LinkedIn to a BDR at Confluent. And that led to us meeting Adam DeLand, who is our account manager. And that relationship's been almost 2 years in the making. I'm like, how often does a BDR get just dropped an opportunity in their hand like this, where I was the one that reached out? So I that's given me so much more like respect, because I'm like, man, like I want to do everything I can to like help, the people that have made our lives so much easier. I mean, whether it be you all or other vendors that we partner with directly. That's kind of my long story, but like it's been fun, and it all comes back to can we trust the technology we're building our livelihood on? And I mean, why we can trust Kafka. Like there's a reason it is the leading streaming platform. And we love Confluent because it makes all the other hard stuff easy.
Yeah, I've been using Kafka since like 2016, and I've always had the managing ourselves. And after my last job, I was at an oil and gas company, and after some terrible snafus we had with managing our own cluster, I was like, I will never do that again, because it is a nightmare. And then also we were heavy users of Kafka Connect, and I was like, and that's its own nightmare additionally if you want to manage. And so I was like, I don't want to handle those two things.
Yeah, I think I've reached the point where I want to know how to handle it, but I don't actually want to do it, and I certainly don't want to be doing it at 3 a.m.
Yeah, that's not the time you want to do it.
The connect piece is really like it's a huge game changer for us, because at least on our side, we have to produce the systems directly to clusters like Brandon's, but there's still people in house that aren't fully Kafka-fied yet. And so for them, they read from our S3 data lake. So it's as simple as just, if we make the topics, then what happens is we dump to S3 for those teams that read from there. And then Brandon just pulls directly out of ours for AVD and other things. And then we also, inside our threat intelligence group, we use Splunk to do our internal visualization. So we dump output to there as well. Recently, we've been building our own custom connectors that will do farther processing outside. So we'll dump to those at that point. And it's really, it makes it a lot easier than, having to write custom, hooks to get this data into just various systems we have.
Yeah, Connect is such a great connector. It's a great way to just join the dots without too much work, right?
It's interesting too, because you observe in data engineering there's this mythical golden like perfect representation of data processing where you can just take inputs, do something, and produce some outputs, and you see a lot of people try and implement that, and it's very hard to home grow and get it right, because there's so many edge cases that you have to consider. And Connect has just had that history and been around long enough that it's very stable, and you don't have to worry about it. Like it pretty much is that golden system of, I want to take some input, transform it, and result in an output. And the non-Kafka teams in-house, it's a hard. I know, I liked it. It was a good one. They use a lot of snapshotting of databases to S3 to do analysis. And those database snapshots aren't incremental. They are full database snapshots. And so that's a lot of cost. And the teams end up having to do logic to say, what are the things that changed? And you get that for free using Debezium. You get that for free in a sense, even just using the standard Postgres connector. Because the data is incremental and changing. And what's really exciting is you can look at those topics and you can actually start to get a sense for what is the rate of change on these tables, like how much activity actually is happening. And it's actually surprising in some cases. You go, actually, this data set updates, we think it updates, every minute, and really it updates maybe every 30 minutes. And being able to actually see that by visualizing just topic traffic is really powerful, because you can also start to glean more insights into what is actually useful in your product and what people are using.
Oh yeah. Do you also do things like we're not sampling? It's clear that we're not sampling this source fast enough, or we need to sample it less often because it's not worth the effort.
Yeah, so we've had a little bit of that on our side. The one thing I'll say that's always important to consider is like, what is the point at which your customers would realize that something is missing? And that
Yeah.
kind of gives you your like wiggle room of how fast you have to be. And generally speaking, you can be a day behind with our data and it's okay. Like it's going to take a day for the customer to notice. So that gives you some wiggle room if you find issues. Kafka, because we can kind of infinitely scale it and be reactive, we can catch up to and replay and reprocess bugs in code so much faster. So instead of in a traditional batch world where you're like, oh, I've identified this problem, now it's going to take me a full 8 hours to reprocess everything. Oh, and now the customers will notice. You can shrink that, let's just say, to 4 hours. And now there's actually a chance
Yeah.
that, yeah, you know what? You probably have a couple customers that might notice it, but it's going to be a handful. The majority of your customers will
Yeah.
never even know that you had a delay. And that is really, I think, another powerful part of using Kafka as part of your data processing kind of infrastructure.
Yeah, because those huge these kinds of scale jobs, you want something that has built into the heart of it the idea of incremental catch up.
Yep.
Right.
And like I'm able to
Yeah.
right now, we consume feed from Jared's topic when we fan out for our production. We're testing out using service accounts. So actually locking down what consumers and producers can read and write to. And I'm able to just go ahead, read his topic into our QA environment and test out that change in parallel, not breaking anything with production, know that it's good, and then roll it to production super quickly.
Yeah, that's another thing that's one of my favorite features of Kafka. You've got like this immutable store of data that you can read in all sorts of different ways without affecting anyone else.
Yep, you're just like, oh, here's my new consumer group ID. Like, let's go and reprocess and see how it goes.
So this is kind of leading into topic retention and compaction stuff, but how much data you're actually dealing with as a working set?
All my topics are set to unlimited, and I think we're at like hundreds of terabytes of data already just from leaving them on unlimited. But our actual data lake the other day was like 11 petabytes or something in S3. So I mean, that's Kafka doesn't have nearly that much right now because we've implemented the last 2 years. And again, it doesn't have to deal with all those snapshots and things that like are just pretty much unnecessary. But for like an example of like, I can give a concrete example, and this kind of plays into how multiple systems interacted, is we sucked in 4.5 billion database records that we downloaded from the dark web and parsed out. So think of like usernames, passwords, credit cards, all these things that we have to track for people that are posted by threat actors. And so we sucked all of them into a topic, or we produced them into a topic and then dumped them out to an S3 connector. And all of that stream, that 4.5 billion records streamed and was saved infinitely. But it streamed out to S3 in like 8 hours or something ridiculous because we just let the default settings be there. And what the problem wasn't that it went so fast. The problem was the next day when that upstream batch system picked up that 4.5 billion records, they were like, what the heck is this? We have never pulled it a single day, and it broke stuff. And so it immediately told us like, oh man, we can't push data as fast as we want to push data, even though we can push data that fast, because we are running now at the point where we're mature enough in our data collection and scale, all the way down at the bottom, where now it's forcing us to improve and reconsider how we can take systems like AVD that are fully streaming, but get those same benefits in systems that are more batch that will break when there's this much information. And
right.
So that was a lot of data.
You need some kind of back pressure on that, right?
Yeah. So what we did, we actually adjusted the topic to stream a lot slower.
I have to say, you're going to win the prize there for humble brag. It's so fast downstream, people can't cope with it.
Yeah, they do great stuff, but like it was revealing about we like as a company we in the last couple of years we've really opened the doors in how much data we can bring in compared to what we used to. So it's revealed to us a lot of assumptions that were being made implicitly simply by not having that much data. So stuff wouldn't break because it was pretty much stable, even like where stable is a range of millions to hundreds of millions. But when you just say, pick an example, start to do billions or hundreds of gigabytes or terabytes in one S3 bucket a day that has to get picked up, it starts to slow down and impact it all the way up to the front end. The actual SQL databases the front end's reading from starts to fill up itself out past the other processing. And then our actual latency in the platform shows down simply because we push so many measurements to show the customers. And so that's where that's where we, Brandon can speak more to just what does the future look like to me at least. And I hope to Brandon, the future looks like a world in which everything is that very much like push data in, a bunch of things take it out, and there's no sort of implied like this will break if there's too much data, like constraints on any sort of piece in the platform.
Yeah, I was going to say, as a kind of comparison, we fan out the data that Jared produces and put it into protobuf. We only do a 7-day retention just because that's all we really care about for now. We're toying with the ideas of having some longer retentions on things. And then all of our topics are 6 partitions. And we're at I think a terabyte is our cluster. And that's one giant feed of data from Jared plus our Kafka connectors and one internally produced data set is about a terabyte of data. And it holds at about that with 7-day retention. And the power two of the Connect stuff is we actually had an upstream database. They did a change to add a column, and that was 12 million rows that got updated because they had to set defaults, right? And so we had our sync connector failed because we weren't dropping off the new field because we did not know about it. I was able to recreate that connector with the new transform setting, go ahead, set it to 6 tasks, run that for about 10 minutes, be caught up, set it back down to 1, and that was a minute of work to scale that up and down. It was super fast.
Nice.
And I think that's, in my mind, when I think about the future, us using more of Connect for transforming, storing database data, rather than us writing a lot of custom code if we don't need to. Let's only write services to transform data if we actually have to have business processing logic that's important in there. But if you are just literally varying data from A to B, you can use a connector to do that. And the connectors are cheap. They're going to be stable, and you don't have to worry about the bugginess. You can focus on your business logic and delivering value.
So is it fair to say that your only real stream processing is going from Jared's cluster to yours?
Yeah, for now, that's a fair assessment.
Upstream of our cluster, that's the case. I mean, that we do in ours, we're starting to use more KSQL to do processing in line, but a lot of the processing we have to do has to hit other APIs and has to pull in other data sources that might not be already in the topic or might change depending on the actual day. And so we haven't put them into a streaming topic. So what we'll then do is suck it off of or consume it. I should say consume versus suck it off the topic. I don't know where you
move on.
Consume it, and then actually say and process that information and then produce it back, because that consumer and producer that lives its own application will then do some kind of enrichment on it. And that enrichment could query an API. It could run another scan. But what's really cool about that scanning system, Horace, is that every time an IP is detected with an open port, that application that's consuming and producing the Kafka will additionally produce that same exposed port to another input topic into Kafka that gets consumed from another application. And then there's this chain of scanning and collection that we build. And a good example is, if we start by scanning the entire internet with a tool, there's a tool called mass scan that just says, here's all the open ports out there. And so what that does is says there's port 22 open on 1.1.1.1. That's Cloudflare. It doesn't have that open, but let's just say it does.
Okay.
Then that will then get produced to a topic that does nmap. And what nmap does is it actually collects the data off that port. And so once nmap gets it, it produces its raw output to Kafka, but it will also, if say another service that has an HTTP port, so if it finds HTTP in another one, nmap will push that to a crawler topic, where that crawler will then actually web crawl versus just scanning the port. And then we keep going farther. Another one is if we find an SSL cert, when we do SSL scanning, there's actually 2 steps you have to do to get the full information, because the world now uses something called SNI. And SNI basically ties a domain to an IP in a bit more complex way. So once we see that SSL service open, we'll push that to another input topic that is going to produce a full SSL record. Subdomains is another one. If we find a domain, but we also find a subdomain, we push that. All of this like chain of tasks of things is all controlled via Kafka input and output topics. And that's in that system called Horus. So that's what makes it so flexible, because anytime we want to add a new thing to do based on the input of whatever we can find in the internet, we simply write a new Python application. We have a bunch of bootstrapping scripts that deploy it wherever we want in the world, depending what providers we're in, which is more than the clouds. We've got 40 or so something hosting providers that we run our boxes in, because since we do threat research, we need to be in sketchy places, but we also need to be in places that everyone else is in, like the cloud.
Right.
Or by the cloud, I mean like Amazon. But Amazon won't let us do scanning, so we use other places to do that. What I'm getting at there is it makes it so flexible. And once we deploy the application, it looks for an input topic in our Confluent Cloud cluster, and then when it gets information, it does its work based on a key in the message, and then it produces it back to a topic that it knows to produce to.
You can almost think of it like a much more scalable and manageable like actor system, basically.
Yeah, I suppose so.
Which is the part that
picture I have in
I
my
really
head.
love about it.
Yeah. The picture I have in my head is like sending out lots of UFOs from the mothership and beaming data back about the planet they've scanned.
Yep.
Maybe I've watched too much sci-fi. There was another thing I wanted to ask you about, because you've got a lot of data, all of which is public, some of which is arguably owned, and you've said you've got passwords, right? So is there a whole governance issue for all this data? Does that come into it, Jared?
Yeah, absolutely. So for the open data that comes off of those passwords are coming off of like data breach records. So think about have I been pwned, where I can go type in my email and I can see that my old Gmail comes up in my fitness file from years ago, because like everybody was breaching that. But to give an example of the governance use case, there's actually another system that's not the password side, like the leak credential, but it's something called Internal Security Suite. And that is where we are actively bringing in information from customers' security vendors and tools. So think of things like CrowdStrike, Tenable, Scanning, Duo. So we'll bring in customer data that says, this user failed a 2-factor authentication. And then we'll map that to the scanning that shows that 2-factor fail was on an endpoint that also has a CV on it based on outside scanning, and start to build like a kill chain of how an attacker, maybe they got through that CVE and then they tried to log in with a leak credential, but they failed the 2-factor auth. And we can actually build that because we connect with the internal systems that have your like proprietary security logs and user logins, all of that. And so that is where the governance comes in. And this is something that we've done really cool with Confluent, where every time a customer joins ISS, which right now is in early access, if they sign up and they connect their Tenable scanner keys, which does internal network scanning, and maybe they connect Duo, what we do is we provision an entirely separate, essentially like container for them inside AWS. But at the same time, we create a topic in Kafka and a full end-to-end streaming set up just for that customer within our cluster.
Oh, okay.
So since the data is within that topic, it's encrypted before it even goes in. Plus, it's all using TLS back and forth to the cloud. The topics will never, they're never going to be in the same spot as another customer's data that's sitting in another topic, even another cluster, Endeavor, QA. And that all happens actually whenever a customer joins. I've written bootstrapping code that calls the Confluent Cloud API and sets up this whole end-to-end, this whole process, and then also creates the container and ECS in Amazon. And then once that container starts, it knows what topic that customer domain belongs to, and then it just starts pulling data from their environment and then pushing it into Kafka via the producer to that topic. And then the front end reads that and shows it just like we do with other things. So that's our coolest example of governance, because we do have to actually keep customer data separate from another customer when it's their internal data. And
so they have their own dedicated front end as well?
In our platform, for every customer, there's we have these things called scorecards. And so the ISS piece, it's their own scorecard. So it's their own backend there. But when we actually bring in their data, it's separate S3 buckets, which is produced from the connector from their own separate topic, and then their own separate container. So all along the way, it's just for that one domain.
You're wearing an awful lot of hats here, from security professional to DevOps.
My PhD is in computer science, and I am more of a software engineer than most people kind of treat me as initially, but I write a lot of code and I build a lot of stuff. But no, I mean, I've been doing more sales recently too for some of the other products we're launching. But all I'll say is that that's what makes it so fun to work here, is because you can kind of do anything that needs to be solved. I mean, if there's someone to solve it, then they're happy to work on it. But I will say that I'd much rather be coding than doing a lot of the other stuff. So that's why I love talking about this stuff.
Yeah, I know exactly how you feel. The two things I want to do with my life are coding and talking about code.
Yes.
So let's just take a peek into the crystal ball to wrap up. Brandon, where do you want to go next?
I want to see more of our internal systems taking a hybrid approach. So it's more micro batching, but the micro batching is driven by Kafka, so that these kind of surges in ingest of data don't cripple systems. Teams can kind of like scale up, is where I kind of see things ultimately going.
But you want to move them to micro batching rather than streaming. Why is that?
Some of the workloads that they're doing inherently need to kind of be batched because of the types of aggregations they're doing. So it's easier to reason about if it's in a micro batch fashion, where maybe say it consumes from the topic for say 15 minutes, does some processing, and then cycles back. That's much more efficient and easier to kind of debug than the full-on, always-on streaming using kind of streaming windows. And I think would be a lot easier for non-engineers to pick up as well. So it kind of increases the surface of people that can contribute and work on these things.
Yeah, that makes sense. You've always got to not just consider the technology, but the people involved in implementing it, right?
Especially when it comes to monitoring and alerting and kind of traceability, it's a little bit easier with the type of work they're doing for it to be a smaller batch, because you could put alerts around very easily, and you could kind of put kill switches in if something's wrong, because you don't always want to stream out the changes constantly. Sometimes you need to have a little bit of a gating and vetting process. So
yes, yeah, I can see that. Jared, what about you? Where do you want to take it next?
Where I want to take it next is a bit more people focused, and like I talked about managing. So my team is a team of hardcore security researchers with been working in security longer than I've been alive. And so I'm a little bit younger, but these people are just rock solid. They've been at McAfee for 20 years before this. They've been in the Canadian CIA. They've done investigations. I worked in intelligence, but these people are amazing too. But what I'm getting at though is when we all started here, there were there was a mix of engineers and security researchers within the threat intelligence group because of the way our teams are broken down. And I have made it my mission to turn every one of my security researchers into not only a competent engineer that's good enough, not Brandon level, but I can say, take Python, go build it, like come back and let's do it. But also making them data pipeline people. So one by one, they've been learning Confluent and Kafka, and to see it click, like, and for me, I remember when it clicked for me, I was like, this is incredible to see that start to like bleed out among our security people has been amazing. So I guess what I'm trying to do is work backwards from the people that aren't super, DevOpsy people, but are very much SMEs in security, and teach them how they can basically themselves start to produce new data that we can use in our platform. And that's what we're actually doing now, because when you give the person that knows where to find stuff in the dark web the ability to code and crawl, but also push it to Kafka, and then I've already specified how to push it, then everything else just works, because usually that would be its own team that does that. Yeah. So that's kind of that's my mission right now is, every last person in our group, whether they're technical or not, should know how to at least interact with the data we have coming through Kafka. At least be able to set up a connector to a new system they're doing, at least be able to go reference the source data. And it's getting there. We're getting a lot closer. So,
and I would say that the thing that really opens up for is improved data quality, because you can reach the quantity, but then you can also make sure that the quantity has quality behind it, because the people actually producing it are knowledgeable about what they're producing, and they can do it so much faster because they have all those years of experience.
And it's empowering for them too, because some of the people that have been in my team a lot longer, they dealt with the RabbitMQs of the past, where they would the answer, you could not add more data even if you wanted to, because stuff would not work. So the changing that mindset, that like, hey, like, you're not going to break it. Like, go set that topic to unlimited retention. I don't care. I mean, the cost is going to be a little bit more, but we'll deal with that later. Right now, we don't want to get rid of information that we might be able to build signals out of. So that is freeing, and it's going forward, it's very much continuing to ingrain that mentality of you can be the master of your own destiny when it comes to producing novel insights for customers.
That is a nice note to end on. I shall write that down and put it on a t-shirt.
Absolutely. Well, I tried.
Jared, Brandon, thanks very much for joining us on Streaming Audio. That was fascinating.
Thanks for having us.
See you around.
Thank you so much. Yeah.
Well, there we go. Not only are they doing some really interesting white hat security stuff, but now I know who I need to speak to if I want to get in touch with the CIA. Contacts in the security services, they're a bit like karate lessons. We learn them in the hope that we'll never need them. Before we go, Streaming Audio is brought to you by Confluent Developer, which will teach you how to make your own web-scale data processing system. We've got tutorials, we've got architectural guides. We don't have a shop for t-shirts yet, but I'm going to try and fix that. And in the meantime, you can find it at developer.confluent.io. Quick side story for you. This morning on Slack, someone said to me that 6 months ago they were listening to this podcast, and now this week they've just joined Confluent. So, Adam, welcome to the party. And yes, we are hiring. If you'd also like to join us, check out careers.confluent.io. And with that, it remains for me to thank Jared Smith and the excellently alliterative Brandon Brown for joining us, and you for listening. I've been your host, Chris Jenkins, and I will catch you next time.